Is it this one? Can you see which screen am I sharing? Lord knows how does this?
We
Are
can
you
see the whiteboard.
okay? Good. I thought you are looking at the Microsoft Teams. Okay. So today we are going. Am I recording now? Okay, I've recorded. So today we are going to learn about binary tree and traversals. Okay. Before we learn about binary tree, you need to learn about trees and graphs. Okay. I'm pretty sure you have learned about this in practical, where tree is basically a graph is basically a connection of nodes that is related to each other, meaning that from one node you can go to several other nodes, and then from other nodes you can go to another nodes. Okay, so that is graph. So it goes to here, and then this can goes to here, this can goes to here, and then sometimes this can goes to here, and this goes to here. This is what we call as graph. Okay, a tree, a graph is basically a chaotic, can be chaotic like this. One point can goes to another point, and it can goes to a different point. Like you can go to from one point to another. There is more than multiple ways to reach. So from A, you want to go to B. There are two ways. But for tree, it's a bit different. Once you a tree is basically a graph or that where it has one root that goes out to different nodes, and each node goes out to another node. But there are no, but each node can be reached by only one way only. Okay, so for example, from A to B, you cannot go to this side and then just suddenly reach here. Cannot. That is what called tree. All nodes in a tree have only one unique path from the parent node, from the root node or the parent node to itself. Okay, and in a tree, we have what we call as the parent node, and we have the child node. Okay, so from the parent, they will always go to the child. Okay, and not the other way around. You can, and you also cannot have one parent goes to another child, and then that child goes to this child. Cannot, prohibited. This is what tree is. Okay, from one node you can go to as many nodes as you want, but you can only, there's only one way to reach that particular node. Okay. Now, how about binary tree? Binary tree is simple. From one node, it goes to two ways, either left or right. Okay, and then from each node, it can go for either left or right, or it can just stay there. So this is what we call as binary tree. Okay, goes to another node. Okay, this is commonly used in data structure or in traversals. Okay, there are also some other types of tree like ternary trees, where they have 3 branches. Each node can have at most 3 branches, but we don't care about that, because if I were to teach you about ternary by skipping binary, you won't understand it at all. So let us just focus on binary only, okay, for this demonstration. Okay, so it can goes only from one node, either it goes left or right, left or right, left, right, left, right, like that. That's all for trees. Okay, so you have learned about graphs, you have learned about trees. In graphs, there's also what we call as so in graph, a tree could be considered as a subset of a graph. Okay, so this is the larger one, this is the small one. And graph, okay, tree is what we call as a unidirectional graph that just branches out lah. Okay, so we're done with graph, we're done with trees, we're done with binary tree. So what are we going to do? How are we going to initiate this? Okay, so let us go here. In the binary tree, okay, we have define, initialize, self, val, L branch, R branch. Okay, so let us just do the demonstration for me to teach you. Okay, so let us do class 3.2. Okay, define underscore init. Okay, so what do we want? What do we need? So from here we have, oh, I forgot about 3.2 node. Okay, oops. So we have learned about node in the linked list, so I don't want to meddle with it so much. So let us do another node. Okay, 3.2 node. Okay, so first, what do we need for a node to act like a tree is that we need the data and we need 2 pointers. Okay, one is the left branch and one is the right branch. This left and right branch will point towards another data, another node of the same kind. Okay, goes to here, and also they also have these two. So let us do that. Oops. Self.var equals what? So since we need to store the data, so we introduce val value and we put val here. That's all. Okay, and then we need self L branch equals to none. We introduce the left branch and right branch. R branch equals to none. Okay, so let us do this. So just to simplify, I'll change this to node only. Node. Okay, so let's see. Root, since I've said it earlier that a tree has a root. Okay, so let us introduce a root. So a root equals to node in bracket, let's say let's say 0. Okay, so this is node, this is the root that holds the data 0. Now what do we do? Root dot L branch equals, we introduce another node, node 1, and then for the right one, R branch equals to node 2. Okay, and then let us do one more. So L branch. So now we have introduced the node 1. Okay, let me just put it on this side and let me put it on the right side. Okay, so the root is here, which holds the node which holds the data 0. On the left side, it goes to another node which holds the data 1. Also, don't forget the branches. And on the right side, it holds another data with a node 2. Now we are going a bit deeper. So we want the left branch of the node that is on the left branch of the root node to have the data 3. So root.lbranch equals node 3. Okay, and then let us do the same for the right side of that same node. So let us do 4, like that. So on the left side, we go to 3, and on the right side, it goes to 4. Don't forget the node. here. But don't bother, this is just for the visualization. Okay, so and then we're done. We're done with this. But brother, how do you want to read this tree? How do you want to read this tree? This is where the traversals come in. Okay, since this tree is not linear, it is, we can call it as an exponential graph, right? Or exponential list, because from one node it goes to another branching node, and then each branch goes to another two branch, and then goes another two branch. So we can't make it into a linear, we can't express it as a linear list unless we do some traversals. Okay, however, if I were to jump straight away to the traversal, you might not understand what the hell am I talking about. What in the world am I talking about? So because it includes some recursion. Okay, so let us go off a tangent a bit and learn about recursion. Okay, so how do you want, what does recursion means? Okay, so to learn what does recursion means, we need to learn what is iterative, which is we have learned before. Iterative means something that we can count up and down by one. Like for example, 1, 2, 3, 4, 5, 6. Okay, so usually what the iterative way of calculating is just by going one by one of this list. Okay, so for example, I've shown here, so the iterative way of doing of finding the sum of first n natural numbers. So for example, 6, right? 1, 2, 3 and up until n. So for example, we take 6. The iterative way is going to add one by one. So total equals to 0 for I in range n plus 1. Okay. Why do we need 2 plus 1? Because this does not include n itself. And one more thing to consider is that for this range, it starts from 0. It does not starts from 1. One more thing to consider. So this is just some refreshing. So for this one, this is just like 1 plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. Okay? Like that. Now, if we do this, we can get the answer. But what if we want to do it on a recursive way? A recursive way is basically, it's a function within a function within itself. Basically, we are telling the function to repeat, to call itself during the execution. Like you can see here, define some number n, meaning that what does this do is that we call, okay, we provide the value 6, and then we check if n is greater than 1. So what do? We return 6 plus sum 5. Okay, so sum 6, it goes to 6. Oh, it checks, oh, this is 6 more than 1, so we return 6 plus sum 5. And then we check 6, we already got the value, we look at the sum 5. We take a look. Okay, 5, is it more than 1 based on our function definition? Yes. So it goes another one. 5 plus sum of 4. For simplicity, I just put sum. And then we take a look. Oh, 4 is greater than 1. So 4 plus sum 3. And then 3 plus sum 2. And then 2 plus sum 1. And then we take a look. Is 1 greater than 1? No, it is equal. So the sum 1 will return 1. So from here, 1 will go back to plus 2, will go back to plus 3, will go back to plus 4, will go back to plus 5, will go back to plus 6, and then it will execute the answer. That's how it That's how it is being done. But then, why do you want to crack our brains and do this recursive and iterative? You don't know when are you going to use. You don't know whether the loop is going to be increased by 1 or not. Recursive is one of the ways, because sometimes in recursive functions, this is basically a function. For example, you can have multiple conditions that updates itself. Okay, probably condition 1 maybe, okay, if something happened, it increased by 1 only. But if something else happened, it increased by 3. But if nothing happened, then it returns. This is where recursion makes sense. Okay, so let us try another simple way. Okay, so for example, define Fibonacci numbers. If n is less than 1, return n. If greater, n plus 1, n minus 1. As you can see here, technically you can do Fibonacci numbers in, what do you call it, iteratively. Okay, you can do Fibonacci numbers iteratively, although I need to crack my brains a bit to find the answer. But there's another way. Because why? Fibonacci numbers relies on two previous numbers, where basically the next number relies on the previous two terms. So for example, so what is the Fibo numbers? Let us see. So Fibo, for simplicity, Fibo. Let us consider what? 9. Okay, the ninth Fibonacci numbers. Okay, so 9, is it greater than 9 is too big. Let us just do 6 as well. 6. 6, it goes back to Fibo 5 plus Fibo 4. And then we check for individually. Is Fibo 5 more than Fibo 4? Yes. If Fibo 5 greater than 2, because if it is 1 or 0, it will return to 0 lah. So if is Fibo 5 greater than 1? Yes. So what do? Return Fibo 4 plus Fibo 3. And as for Fibo 4, it will return Fibo 3 plus Fibo 2. Okay. And then you can do another one and another one and another one. So, but then brother, hear me out. Isn't that basically means you are going to call each of the function many times? Well, if you implement this along with an array of Fibonacci numbers, then something will something special will happen. Because let's say you are going to save all these numbers. Like for example, Fibonacci 4 and Fibonacci 5 is being saved in an array. Okay, for example, Fibonacci 6, 5, 4 is going to be saved in some I don't know lah, some kind of an what do you call it, an array. So when they want to call a similar Fibonacci numbers, oh, we have already called this function before, so we are going to just use the value that we got from the array. We don't have to call lesser by. Okay, this is, let me just, yeah, I should have done this in a dynamic way, but I forgot that dynamic programming is very tough for you guys to understand though. So yeah, recursion is very useful in dynamic programming. And binary tree is one of the can be used as a binary dynamic programming. But for the sake of making sure you guys are not lost for some not unnecessary, it is necessary, but for the sake of today's subject, I'm not going too far from the tangent. So just take what it is lah. Okay. So let me just use the actual implementation for the binary tree. Okay. So how are we going to use recursion in binary tree? Easy. Well, for me lah. For you guys, I don't know. So what do you do? What do you want to do? We want to make it, we want that function, okay, to traverse into a node, okay, and for each node, so this is like since the function itself is repetitive, meaning that it can call itself many times and basically doing the same thing. So what we can do is that we can see going inside this function and we check, is there any left branch? If yes, we go to the left branch first. Else we check, is there any right branch? We go to the right branch. If there's no branch at all, we just go back. Okay? So for demonstration, let me just do this. So let us define not define. Let's see. Define recurse. Okay. So what do we do? If node.left branch exists, we go to node.left branch. Recurse node.left branch. And then another one, if node.r branch recurse node.r branch. Okay. So we have done. If there's a node on the left branch, we go to the left. If there's node on the right branch, we go to the right. And if there's none, we just return. This is where recursion works, because how do you want to traverse the binary tree using iterative way? You cannot use loops. You cannot use 1, 2, 3, 4 because the branches are crazy actually. Can be as crazy as they want. So we need to use recursion. Now, this is the recursion. Let us try to do traversal. So we change recurse to traverse. Let us take a look here at here. So for example, I'll consider putting it here. What is wrong with this? Oh, because okay. Oh, I forgot to do this. Recurse root. And if you run this, you can see that it begins from 1, 0 to 1 to 3 to 4 to 2. So basically we are changing, we are reading the binary tree in some kind of a way. Okay, what is that way? That is what I'm going to tell you. Notice that if I put the print node file on the beginning, it becomes like this. What happened if I were to put it in the middle? It becomes a different order. Ah. And what if I put it after? It becomes another order. What is this, brother? Is this some kind of a magic? Well, yes, for those who does not understand, but for those who understand, this is some algorithm. Okay, this is the part where we are going to learn about uh, traversals. Okay, the location of where we put the print stuff determines what kind of traversal are we going to do. Okay, so for example, so what I taught you from here, this, if I put the print function before we go into any of the branches, this is what we call as pre-traversal. If I'm not prefix it, pre-order traversal. This is what we call as pre-order traversal. Pre-order traversal. Okay. If I put the print function between the time where between after traversing the first branch but before traversing the second branch, this is what we call as in order traversal. Okay, for now I just put in order recurse, but actually it's in order traversal. Okay, if I were to put it after we went through both of the branches, this is what we call as post order traversal. Okay, pretty sure you guys have learned how do you guys visualize it during the theory class. But if I were to show you, I forgot. Order roots. Also print this and this, and we are going to get this. On the top is the pre-order, meaning it reads the data in the node first and then it goes to the left branch, goes to the branches. In order, it goes to the left branch first until there's no more left branch, then it read the data and then it goes to the right branch. And then the post order is basically it goes to both branches first, then it reads the data. Self-explanatory. That's all. For binary tree and traversals, also recursion. Same here as well. Print, node, yada yada, and then goes down. Yep, same one. Okay. So is there any question? Binary tree and traversal is kind of like a heavy topic for you guys because the algorithm is quite complex. So do you guys understand?
I think for those who have take it in the class who really follow the theoretical this thing, they should be able to catch it up. Since it's the traverser actually. It's not the other part of it.
Okay. I'm pretty sure my tasks for the traversers are quite heavy. So let me just check it first. Let me just check it. Before that, let me just give you the magic word for today's class. Oh, lol. The recursion is supposed to be the next class, but I just put it there. Okay, no worries. Notepad. So this is the code for today, traversing trees. Okay, let me just read the tasks for you guys. What are the tasks? If I'm not mistaken, the task for binary tree and traverser as well as recursion is quite hard actually. So let me just read it out. Oh, this I forgot. Okay. So for task number 5, especially 5C, is the hard part. I really want you guys to really understand what is recursion and traversal. So task 5 is basically like a mini project. A mini project because it is very hard. Not gonna lie. Basically, what it does, okay, is that it prompts you to find the deepest branch. Okay, so you need to find. Uh, I've provided the tree there. You guys need to find which branch is the deepest within the tree. Okay, so you don't know how deep the branch is. You don't know what is the shape of the tree. Even if you can visualize it by drawing on the whiteboard, how do you want to tell the program to imagine the tree is? So task 5C, I specifically put 4 marks instead of 3 because this is this is the hardest task I've ever given to you guys. Okay. Okay, so I don't want you guys just copy and paste the print order, in order, post order. You can just copy my code and just get two marks. As well as the insert sort. Insert sort also inside my code. Although I like you guys to do it on your own, but in reality, some of you guys are just going to copy it, just copy and paste, not by typing it one by one. So that's why 5C is there, just to see your understanding of recursion. Okay. So for this one, I might consider giving you 3 weeks. Okay, 3 weeks to finish all task 5 because for the GUI, I did not give you any task because you guys already got your projects. Okay, so for task 5, I give you guys 3 weeks to settle down. Unless if you finish early, then I will be happy lah. So I don't have to worry about marking your task anymore. So is there any more questions before we end the class? No one?
No, I think.
No?
Atima, what's the next task? Because they need the GUI for their project. To
The
complete their
next
project.
the next class, task 5 would be the last task for you, for the class. Okay, I'll be checking
Okay.
task 4 from previous week, and
Okay.
task 3, I still haven't got any submissions from group 2. I don't know what happened to you guys, but since I've said it before, I won't be checking anymore. Okay,
Yeah. There is
for
no need.
so for task 3, no need to check. I won't check anymore. Task 4, I'll be checking after this session. Task 5, I'll be giving you guys 3 weeks lah, just for the task 5C. No need GUI. For the GUI, next week, there will be no task. Okay. As well as the following week, week 6 and week 7, I won't give you any tasks at all, because you guys are going to focus on implementing GUI for your program. Okay, that will be your project lah. Okay, but for task 5, I will be giving you guys 3 weeks, just for the sake of giving you some time to do 5C. That's all I think, madam.
All right. I think so that yeah, they will be able to fix up the what do you call it? The project. The GUI is very important for them. So I want them to finish up. Okay. I
Okay.
think that's from
Okay.
me.
From the class, from the students. No one. Don't worry. This is the task 5C is basically the hardest task, but don't worry, you can do it. Any questions from the class before I begin marking your task 4? If no, let me just stop recording this session.